Underground utility failures can be devastating for manufacturing facilities. These failures can result in worker injuries, property damage, and create high-risk situations while the utility is out of service. Furthermore, the costs associated with the emergency repairs and production downtime can be astronomical. If you are responsible for operating, maintaining, or repairing a decaying utility system, you are well aware of these challenges. Hi, this is Todd Green with Matrix Technologies, and we are here to help. Matrix Technologies is a full-service resource for engineering, automation, and information system design. Industrial manufacturers around the world have trusted us with their most challenging infrastructure projects over the last 40 years. Manufacturing, refining, and specialty chemical facilities all across North America are facing utility infrastructure challenges. Large campus sites and facilities have utility networks that are comparable to small municipalities, complete with sewer, water distribution, power, communications, natural gas, and water and wastewater treatment systems. On top of the basic utilities, most manufacturers have advanced utility systems including high-pressure firewater, steam, process cooling, industrial waste, nitrogen, compressed air, and other air handling systems. Each system is unique and requires an in-depth knowledge to properly design, maintain, repair, and construct. Facilities with newer systems can also experience operational issues, inefficiencies, or premature failures if the utility was not planned or designed properly. Considerations that can be overlooked range from not mitigating the potential for water hammer to not considering soil corrosivity when specifying materials. All of these considerations may seem trivial early in a project, but can be costly over the life of the system. Buried utilities are often more difficult to manage due to accessibility, not included in a typical preventative maintenance program, and ultimately forgotten until an issue arises. Many sites have been in business for over 50 years and operating with the original infrastructure in service. When you begin experiencing failures, you realize the aging infrastructure is nearing or has exceeded its service life. With miles of utilities to evaluate, it can be overwhelming and unclear on how to approach a major infrastructure rehabilitation program. Matrix Technology has completed numerous infrastructure studies and master planning programs for industrial clients. We start by working with the facility stakeholders to understand their goals and develop a customer approach tailored to their needs. In general, our infrastructure evaluation, rehabilitation, and replacement strategy consists of the following phases. First, preparing a business case and justification. Second, data gathering and condition assessment. Third, identifying options for rehab or replacement. Fourth, master planning and capital forecasting. Next is detailed design. And finally, documentation and management of the system moving forward. The first step in the process is securing funding to initiate a program and investigate the decaying utility system. It can be difficult to develop a return on investment for the utility system programs since investing in these systems rarely has a direct impact on production profitability, and predicting the frequency of failures can be subjective. However, these systems are essential for production, and when a failure does occur, the costs become clear. To best present this case, a risk matrix can be developed that compares the likelihood of failure versus the consequence of the failure. Historical information should be included in this risk review, including cost of emergency repairs, production downtime, and any environmental costs. How bad is it is usually the next question. The data gathering and condition assessment phase usually answers this question. Drawings and historical records are used to identify the physical characteristics of the utility, such as material, age, and size, as well as conditional information such as soil conditions, corrosive potential, and surface loading. By combining this information with maintenance and repair history, one can prepare an office approach to quantifying and classifying the condition of the utility system. This information can be used to justify and prioritize spending or be the basis for a more direct testing program. Methods for field condition assessment include visual, leak detection, wall thickness measurements, and corrosion potential testing. These test methods can add a lot of upfront cost to a program. However, the testing can better indicate remaining useful life and optimize construction spending. With the condition assessment complete, the team can now identify and select options for the program. The first is whether the service life can be extended or restored economically, or if replacement is required. Many rehabilitation materials and techniques are available depending on the application and site conditions. If replacement is selected, an appropriate material must then be specified. For buried piping, traditional materials include reinforced concrete, ductile iron, and PVC. New materials may provide longer service lives if corrosive conditions exist. These materials include high-density polyethylene, propylene, and fiberglass reinforced piping. With a material selected, the team can also choose from a variety of construction techniques, such as open-cut excavation or trenchless installation methods such as directional drilling. A thorough cost-benefit or risk-benefit analysis can help select a material and technique that best fits the site conditions, service requirements, and budget constraints for the program. The next phase includes master planning and capital forecasting based on the condition assessment and the selected installation materials and methods. Often these programs extend over multiple years. Our cost estimates can be prepared and aligned with the duration and budget for the program. Tools developed during this phase are usually schedules and cash flows for each year. Typically, conceptual designs will be created during this phase and be the basis for cost estimates and scheduling. It is essential that the utility system designs consider the overall site master plan and include future demands in the sizing of the new infrastructure. Detailed design will align with the construction phases of the program. Sizing and capacity of the system will be confirmed and construction and contract documents developed. Preparing the final details requires a good understanding of existing site conditions, especially for buried utility construction projects. Surveying and underground utility locating will help plan for and mitigate the risk of encountering unknown obstructions. During construction, it is important to document as-built locations of the buried utility system. This documentation can be critical for future maintenance and rework of the system. A geographic information system is an excellent tool for storing information and managing buried utility systems. The GIS can be a single source of truth for data management. Also, the tool can be used to track progress of the replacement and rehabilitation program, as well as incorporated into a preventative maintenance plan. As an independent partner for our clients, Matrix Technologies can guide and manage a program from start to finish. These services often include initial studies, design, procurement, construction management, and even full EPC services. Here at Matrix, we lean on our in-house experts to ensure you have the best team and a cohesive project approach, with no gaps between each phase or between owner, engineer, vendor, or contractor. Our goal is to provide the right level of service to fit the needs of each project. For more information, check out our Matrix on Manufacturing website and the other videos on our Matrix YouTube channel.